right, so today we're going to talk about the binomial theorem. This really has nothing to do with probability that we've been working on, but what it does do is it has another use of combinations. Now, I can't quite figure how in this textbook they put this lesson, 7.4, before 7.6, which was the counting principles. So I've rearranged it because we need those combinations for what we're doing today. So we've learned that combinations are used a lot with probability. And if you can imagine that back in the early days when they were just talking about combinations or probability, actually it was in the 1600s, there was a mathematician, Blaise Pascal, that he wrote a book on gambling. And it was all the rage. But think about that. If he was doing probability over and over and over, don't you think he'd create himself a cheat sheet on all these combinations so he didn't have to recalculate this because he did not have a calculator? So that's what this is. It's just kind of an organization of every which way you might do a combination. So if you look at what I've got, I've kind of created it in a pyramid fashion here. This is combinations of 0 to 0. Then we have, this is called row 0. This is row 1. It's 1, choose 0, and 1, choose 1. All right, if you had two items, you could do 2, choose 0, 2, choose 1, 2, choose 2, and so forth, and so forth. And this is going to get bigger and bigger as it goes. And so we do need to know, this is called Pascal's triangle. And what we did in class is we went ahead and calculated all of these different combinations, and we created this pyramid so that we would then know what each one of these values was. So since you're on your own watching the video, I'm just going to create that for you on the next slide. So we did combinations of 0, choose 0 is just a 1. And then, ironically, when you have one item, there's only one way to choose none of them, and there's one way to choose one of them. But then here's row 2. It starts off also with a 1, 2, 1, and I'm just going to start building this. This is row 3. This was row 4, and we could go on and on. I'm not going to go, I guess I'm going to go as far as I can fit, which is probably about, well, I might stop right here, to be honest. Now, you have to know this Pascal triangle without having to calculate it. But you know what? It's really not that hard. It's got some really cool patterns in it. One pattern that we're not going to use, but I find kind of interesting, is something they call the hockey stick pattern. And any way that you draw a hockey stick, like this right here, these numbers right here will always add up to the toe of the hockey stick. So 1 plus 2 plus 3 plus 4 equals 10. And you could do it with a short little baby hockey stick. It can be a long, and the longer this, or the more rows we add, the hockey stick pattern still holds all the way through. Okay, kind of cool. Not really applicable to what we're doing, but you know. So let's talk about one that we do want to use. And it is ultimately how I created this. I don't know why that dot is there. I can't get rid of it, so ignore it. How I created this. It's not that I really had it memorized, though I kind of do, but I wouldn't have to. What's kind of cool is any particular number is always the sum of the two numbers above it. So this 6 is the sum of 3 and 3. This 4, the sum of 3 and 1. This 5, the sum of 4 and 1. This 10, the sum of 6 and 4. So let's go ahead and just add in the 6th row using that pattern. Notice that they always start with a 1, and then the next one's going to be 1 plus 5 is 6, 5 and 10 is 15, 10 and 10 is 20, 15, 6, and a 1. So futuristically, that's how you're going to build this. You're just going to start at the top and build it. And you'll build it to whatever row you need it. To some point, we don't want to build this to 10 rows. It's going to take forever, and it's going to get huge. Really, the 6th is probably the farthest we would ever take that. The other thing that's worth noting is when you're doing, remember what these are the combinations. And so combinations of anything choose 0, these were all choose 0, choose 0, choose 0, choose 0. Okay, so a choose 0 is 1. There is one way to choose nothing, and that is to choose nothing. Likewise, over here on this is basically choosing all. So this was 4 choose 4, 5 choose 5, 6 choose 6. There's only one way to choose everything, and that's just to choose everything. The next row in is also worth noting. So like this is 4 choose 1. There's 4 ways to choose one item. You choose the first one, or the second, or the third, or the fourth. And so anytime you're choosing one, it's always that number. And choosing one is basically the same as choosing all but one. So here, this is a 3 choose 2. So you're choosing all but one. This is a 4 choose 3. You're choosing all but one of them. So that's kind of nice. And then the inner part is where you start looking at those sums to build this. Now, ultimately, this is where we're going to see this happen. Now, you probably have not seen this expansion before. This is called binomial expansions. If you were to take a binomial to the first power, here's what it would equal. If you take a binomial to the second power, remember our shortcut for that. We would do a squared, we would multiply the 2 and double it, and then we'd square the last term. But that's about as far as it gets on shortcuts because we don't distribute. That's a biggie. We do not distribute powers. So if I were to cube this, I'd have to write it out 3 times, FOIL it all together, and voila, here's what you get. To the 4th power, here's what you would get. 5th power, here's what you get. All right, so really what I want you to notice here, and you probably don't see it on your paper as well as maybe you can see it here, but look at your coefficients on all of these. This is a 1. And a 3, 3, and a 1. Here's a 1, 4, 6, 4, 1. To the 5th, 1, 5, 10, 10, 5, 1. Does this look familiar? I'm hoping that you looked at that previous Pascal triangle enough to know, hey, you know what? These are Pascal numbers. This is the 5th row of Pascal's triangle right here. So if I am taking any binomial to the 5th power, I'm just going to use Pascal's numbers, and those are going to be the coefficients. How easy is that? That's 1,000 times easier than foiling all day long. Now, it's more than just that, though, because you do have, oftentimes these are numbers, not just variables. So let's look at what's happening to the variable, or the term, I should say, that's right here. So this A, let's look at what happens to it. It starts off to the 5th power. That's because this is to the 5th. But now look at what happens to it as you go from term to term to term. It just keeps declining, declining until on the last term, it's not there at all. So the power keeps going down, 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 down. Now let's look at the second term, the B. Notice it's not there to begin with, but then it's B to the 1st, B to the 2nd, B to the 3rd, B to the 4th, B to the 5th. So as the first term works its way up, the second term works its way down. So there's 3 things involved in this. And so I'm done with the FOIL game. I'm never going to do that again. There's 3 things. There's the Pascal number. Let's jump into the middle here. There's the Pascal number. There's the first term to a power. There's the second term to a power. And if you can kind of keep track of those patterns, you can we're going to take 2 steps to write it out because it's going to get fancier than this. If it's as easy as this, it's going to take 1 line and I'm going to write the answer. But I'm going to throw numbers at you, and then it gets a little bit trickier, but not too much. Let's give it a shot. Now, up here on top, I've kind of shown you that this is the formula you would see kind of in a textbook. This is what it would look like. If you're going to take a binomial to a particular power, you're going to first grab the combination number. So it starts off with this is basically from Pascal's triangle. It's some power to the 0, then to the 1st, then to the 2nd, all the way until you've done all of them. The first term is going to start off at this power, while the second term is going to start off to the 0. And then this one is going to work its way down, so it's n minus 1, n minus 2, while the B term, the second term, is going to work its way up. It starts off at 0, 1, 2, all the way till you get to the end. Okay, so these are the 3 things that I have to have. Let's give it a shot. I'm going to go to the 5th power. Now, this is where you're going to look back at your Pascal triangle. I'm not actually going to type this in or this in or this in. I'm going to have Pascal's triangle drawn to the 5th row, and I'm just going to peek back and say, all right, the first number is a 1, then it's a 5, and we'll go from there. So the first term is going to be a 1. And then the x is going to be raised to that highest power, while the 3 is raised to a 0. Plus. Write little on this, sorry. If I'm going to go to the 5th power, notice how many terms I'm going to have. The combinations start off at a choose 0 and work their way up to the, in this case, choose 5. So this is going to have 6 terms across here. So write little. Okay, the next number from Pascal's triangle is a 5. Now x is going to work its way down. 3 is going to work its way up. Oops, grabbed the wrong thing there. Plus, the next number on Pascal's triangle is a 10. X is going to work its way down. The 3 going to work its way up. Plus, another 10. X is now squared. 3 is now cubed. Plus, next one is a 5. X is now a 1. The 3 is now a 4. Oh, I should have written a little bit smaller. Last one is a 1. The x is now to the 0, and the 5, oops, not the 5, the 3 is to the 5th. Squeeze that in, sorry. Okay, so that's my one line of work. The rest, I'm just going to write. This is the answer. Here we go. I have 3 things that I have to multiply together for each one of these terms. So I have a 1. This is just the variable part, but this is now a number, not a variable over here. So I have a 1, and this is just a 1. So this is just an x to the 5th. Plus. Okay, now I have this 5. This is the variable part. This is still going to be a number. That's a 3 times that 5. So now that coefficient is a 15. And right here, you start to lose that Pascal triangle number as you go across because you're multiplying things together. But in your first step up here, you'll see the Pascal triangle numbers. The final answer, you don't see it anymore. Here we go. I have a 10 times a 3 squared. That's a 90. The x is going to be a cubed. All right, next I have another 10, but this time it's times a 3 cubed. That's 27 times 10 is 270x squared. Plus, this time I have a 3 to the 4th power. That's 81. I know you knew that. 81 times 5. Anybody? It's 405x. Plus, and then I have this 1, and I have a 3 to the 5th. I should have checked this earlier, sorry. Sorry, let's clear my calculator. 3 to the 5th, 243. Some of you maybe knew that. Smarter than me. Okay. There you go. You're done. Look how easy this is going to be. Like in Algebra 1, your teacher maybe gave you this big challenge problem, testing your FOIL skills. Now you know better. Let's try one that has a little bit more going on. Okay, this time I put the number on the front, and you definitely will have problems where you have a number here and here. Okay, so anything can happen here. In addition to that, I've changed it to a minus sign to mix it up a little bit, and I've put a power on the binomial on the inside here. Okay, so I've tried to mess this up, and let's see how that plays out. Tell you what, the pattern is still there. I'm going to start off with a choose 0 and work my way to a choose 3. So that's going to be 4 terms I'm going to have. So I don't have to write quite as small this time. All right, so I'm going to start off. It's a choose 3, so I got my, I'll just throw it up here for us. It's a 1, 3, 3, 1. That's the 3rd row of Pascal's triangle. So I'm going to have a 1, and then I'm going to take this 2x, and I'm going to raise it to its highest power, which in this case is a 3. And then this is where you don't put a minus sign here. It's not that I have a subtraction in the middle of these. This is all going to be one single term. So I don't want subtraction going on in the middle of that term. What's really happening there is I'm going to take this negative y squared, and I'm taking it to the 0 power. That's how that needs to look. Those parentheses are mandatory. Don't just let there be a minus sign in the middle of this single term right here. Then I'm going to do a plus sign. Okay, my Pascal number is a 3. 2x is going to work its way down, so now it's squared. Negative y squared in parentheses, working its way up. Plus another 3 for the Pascal number. 2x is now going to only be to the first power, while the negative y squared is now squared. Plus, now you have a 1. The 2x is now to the 0, and the negative y squared is to the third. All right, so there you just get in your groove and you just write it all out. Next part, you multiply it together. So as far as numbers, I now have the Pascal number, and now it's the front term. This is a 2 to the third. That's an 8 times the 1. That's just going to be an 8. X cubed. And then I have this negative y squared being taken to the 0 power. That's just 1. So that's not going to change anything. So 8x cubed is my first term. Plus. Now I have a 3 times a 2 squared. So that's a 12. X squared. And now what I have is a negative y squared to the first. Power to a power, we just multiply. So that's going to be y squared. But this negative is really like a negative 1. And a negative 1 to the first power is negative 1. So not only am I taking a 3 times a 2 squared, I'm also taking it times a negative 1, which means my 12 is not really 12. My 12 is negative 12. So that changes my plus to a minus. And then I have my y squared there. Now, before I write plus or minus here, let's think ahead so I don't have to come back and erase. Do you think the y term is going to be positive or negative here? It's not this that I'm looking at, it's this. I'm taking this entire term and squaring it. That's going to make that go positive. So I'm okay with a plus sign. But let's get the pattern figured out. What do you think this one's going to be? Well, now the negative is being taken to the third power, which is going to make it be a negative 1, which means this is going to go negative. And ultimately what happens is it flip-flops. The first one is always to the 0, so it's going to be a positive. But then every time you take it to an odd power, it's going to be a negative. You take it to an even power, it's going to be a positive, odd, negative. So it's going to alternate positive, negative, positive, negative. That's going to happen every time you get a minus sign right here. Okay, so I know now this is going to go to a plus sign. I've got a 3 times a 2 to the first, so that's a 6. The x is just to the x power, and then this is now going to be a y to the fourth. Next term's got to be negative. I've got a 1, 2 to the 0 is 1, everything's just a 1. Probably don't even need to write the 1. The x is to the 0, that's going away. All I have left is this y to the 6th power. Power to a power, you multiply those. Okay, there's our answer right there. Now, what you might have noticed on the previous one is that the powers sit there in decline because I only had one variable. This time I have two variables. One of the variables will decline while the other variable goes up. But what's sort of interesting to note is there is still a pattern to those powers. So this is a 3. If you add these up, it's a 4. Add these up, it's a 5. There's a 6. So there's all these patterns when you do this to kind of help you maybe check your answer, make sure you didn't make any silly mistakes. Now, if you wanted to, it wouldn't be a bad idea. Maybe pause, go work on your homework a little bit. It's just a worksheet probably, and practice that skill before you jump into this. Once you feel good at that, maybe come back to this. Or just jump right in with me. So here's what we're going to do. These, they still take a little while to do. As you start having higher and higher powers, they'll take a little bit. And so I can't give you a ton of them to do on your homework, but what I would like you to do is start noticing patterns within that. And so to have you notice those patterns, I'm going to give you something crazy. I'm going to take it to the 10th power. But I sure as heck do not want you to multiply that whole thing, or not even multiply it out. I don't want you to create Pascal's triangle to the 10th row. That'd be ridiculous. I don't want to have to grade well, it actually would be 11 terms, remember, because it starts off at a choose 0, so there's always one extra term. I don't want to have to grade that. But what I'll do is I will have you find one single term out of that expansion. Now, if you do the whole dang thing to find one term, you're crazy. You're going to run out of time on the test, and it's going to take you 2 hours to do your homework. So instead, let's figure out what the pattern for this should be. It says find the coefficient of the x to the 6th term in this. Now, this is a little tricky to pull off because I can't flip back to the slides easily when I'm making a video. So you have to kind of look back at some of those previous ones. But what I want you to notice is if I'm looking for the x to the 6th, okay, x is the first term here. Let's look at what's happening on that. The x to the 6th, well, here would be x to the 10th. This would be x to the 9th. This would be x to the 8th, x to the 7th, 6th. Okay, so here's what I do know. I know that of the three things, I'm going to have a combination, which again, I don't want you to build Pascal's triangle to the 10th row. So I'm not going to know what this number is. I'm actually going to have to calculate it as the combination that it came from. So there's going to be a combination of 10, choose something I don't really know yet. I'm going to put a question mark there. And then I know there's going to be a 2x raised to some power, and there's going to be a -3 raised to another power. Now, I know that I want the x to be raised to the 6th power, so that's a giveaway right here. That's going to be a 6. Now, if you look back at our previous slides, it probably shows it better than this does right here, but I want you to look at the example that I just talked about that was to the 3rd. And what did I tell you? Nope, I don't even think it's that one. I think it's the one before. This is bad. Sorry. Pause. Hang on. All right. I went back and grabbed it off of that slide. So now you can peek back at yours and see it better. But this was the slide where we did x plus 3 to the 5th power. And this was the first expansion when we were showing our work. And this is just the first 3 terms. It went on and on. What I want you to notice are these powers here. What do you notice about the powers on all of those? And you can look back. What do you notice happens with those powers? Yes, one is decreasing, one's increasing, but look at the sum. Every time it added up to 5, didn't it? If you look, every time it adds up to 5. So it's like this right here, always going to add up to n. And n minus 1 plus a 1, it's going to add up to n, which is this. So what do you think if I'm taking to this 10th power, these are going to have to add up to? 10. That's a giveaway. What's this going to have to equal then? 4. Yes, that's right. Okay, so now the next thing I want you to notice is on these combinations, and here is where this might be a better example of it. Notice that whatever you're choosing here, see this is a choose 0, that's the power on the B. Choose 1, it's the power on the B. Choose 2, it's the power on the B. So since this is a 4, that's what this is going to be. So I'm going to erase my question mark and put a 4 there. Okay, so what you want to do at this point is make some sort of note to yourself. I wish I would have scooted this over a little bit, but ultimately the sum is equal to the power. And when I say the power, I mean the 10 there. Okay, the other thing that you need to know is that this and this are equal to one another always. And with that information, you can figure out what the coefficient on the x to the 6th term is if I were to expand this all out, which I would never want to do. So I'm going to do it. I'm going to go to my calculator, and I just have to calculate those 3 things and multiply them together. So I'm going to go 10 and go into my probability menu, choose 4, and that's a 210. I'm going to come out here and do it where I have a little bit more room. That's a 210. The next term is going to be a 2 to the 6th power. Do you know what 2 to the 6th is? 64. All right. And then the next one is going to be a -3 to the 4th. Now, I know that that's going to end up being positive, so I'm not worried about the negative. 3 to the 4th is an 81, and then I'm just going to take 210 times the 64 times the 81, and this is the coefficient. I had a typo, sorry. Boom, boom, boom. Okay. The coefficient on the x to the 6th term would be this. So could you imagine if you were expanding this all out and you had coefficients that were that large, this would take up, a big piece of butcher paper, not your notebook paper, to write it all out. So here is the coefficient on that term. Okay. So now the next one we have here, I've made it a little trickier. I guess the last one was a minus, but that didn't really matter to us. But here I threw in a couple variables. So let's see how this is going to play out. We've got the pattern figured out. So we've got this. It's combinations of 11 this time. Choose something. I'm going to put that on hold for just a second. My x is going to be raised to a power, and my negative 4y is raised to a power. Now, the coefficient I want is the x to the 7th. So this is a 7. And remember that these have to add up to the power. So they add up to 11, which means this is a 4, which actually this was the giveaway for that anyway. I didn't even have to know that. I could have figured this out. But also remember that since that's a 4, this is a 4. So then I'm going to type in my calculator in the probability menu of combinations of 11, choose 4. The x to the 7th is not going to introduce any number for this, so I don't have to worry about that. And then it's going to be a negative 4 to the 4th. Oh, dang it. I was hoping this was going to end up a negative, but I have an even power on that. So here's another example where the negative ends up going away. And I'm just going to take it 4 to the 4th then and multiply that all out. And so then my coefficient on that term is 84,480. All right. Here's a different way for me to kind of quiz you on your knowledge of this. Again, I'm going to get crazy. I'm going to ask you for some term way, way, way down the line. So I'm going to the 10th. I'm going to the 11th again. These are the same quantities, but I'm changing my question here. Instead of asking for an x to the 8th term or something like, or I'm sorry, x to the 8th power, which kind of handed me that first power that I needed to get started. Now I'm just going to ask you for the 8th term. That's a different deal. That's not the same thing. The 8th term doesn't necessarily have the x to the 8th power in it. Here's what this will look like. Combinations of 10. Choose, I don't know yet. Let's wait and see. 2x is going to be raised to some power. Negative 3 going to be raised to some power. What we have to do is notice the pattern as this goes down the line. What's going to happen on the 8th term? And I think this right here is what's helpful. It always starts off with a choose 0. Then it's a choose 1, choose 2, choose 3. So since it starts off with a choose 0, we always have one extra term. There gets to be an extra term on the front of it. So the first term is a choose 0. This is my first term. The second term is a choose 1. The third term is a choose 2. Do you notice what's happening every time here? Okay, what I'm choosing is always one less than what term I want because it starts off at the 0. Since I want the 8th term, what do you think my combination should be here for me to choose? It's not going to be a 10 choose 8. It's going to be a 10 choose 7. It's always one less. Okay, so let's make a note here to ourselves here when we're doing this. The term, actually, let's do this. Combination, I don't know what the quickest way to write this. Combination is choose I don't know, this looks terrible. One less than the term number. I don't know what I was doing there. I don't know what the quotes are. I don't know what the parentheses are. Combination is choose one less than term looking for. Maybe you can write something that makes more sense to you. Okay, so that's our starting point this time. So that's a 10, choose 7, which means, remember, if that's a 7, this is a 7, because that whole deal still holds. And if that's a 7, these powers have to add up to 10, so that must be a 3 right there. So those patterns will still hold. All right, so now in my calculator, I'm going to do the 10, choose 7. Okay, that gets me a 120. 2 to the third is an 8. And a no, here we go. Finally, I'm going to get a negative number. 3 to the 7th is 2,187, but it's going to be a negative 2,187. And if I multiply that times the 8 and times the 120, getting this big old negative coefficient. Now, notice also the way the question is worded this time. It says find the 8th term. So the 8th term actually includes the variable. The last question was find the coefficient. If I want you to find the 8th term, it's this, and then my x is to the 3rd power. So include the variable in this. This is a 9 here. It didn't look good. Okay. All right. Last one is on you. Find the 5th term in that problem. Take a minute, pause the video, go do it on your own, come back and check and make sure you did it right. But don't wait for me. You got to pause the video. All right, here's what I've got. Ironically, the 5th term of this actually matches the term that they were asking for in that previous slide. Did you catch that? Don't forget on this one also include the variables, but if they just ask for the coefficient, then don't include the variables. Okay, that's all we've got. Good luck.